We will have a quiz on this stuff on Tuesday next week. Sound good? I made the quiz, so all the answers are 0. If you believe that, I have more sarcasm I can give you. All right, so I'm on page 201. I'm just going to work out the first and the fifth problem. Problem number 1, y equals negative 4x plus 7, 2x plus 3y equals 7. And they want to know if 2 comma negative 1 is an answer. Okay, you will see a problem just like this on the quiz next week. Okay, so this is a definite for the quiz. So I want to verify this works. So I'm going to take my x and my y and I'm going to plug them in to both equations. So my y value is negative 1 equals negative 4 times 2 plus 7. Negative 1 equals negative 8 plus 7. So negative 1 equals negative 1. That's true, right? That's what we're looking for. Then I'm going to plug it into the other one as well. So I have 2 times 2 plus 3 times negative 1. Does that equal to 7? I don't know. So I get 4 minus 3 equals 7. So that means 1 equals 7. Is 1 equal to 7 this week? No. So is this the solution? No, not the solution. Okay? So on this type of problem, I would expect to see work done. Don't just go circle yes or no. Okay? You don't circle. If you circle yes or no and there's no work shown, I will not give you credit for that. It's pretty easy to get the credit, get the points. And then we did number 5 as well on page 201. All right, let's see. I got to dig up my graph. Let's see. Copy file. Paste our file. Paste. All right, kind of covered it up a little bit. Let's reduce it down a little. All right. Number 5 says x equals y is the first one. So can I flip that over to make it this? Are those the same thing? I think so. So I have to realize that I'm going to have this, which means I have a y-intercept at 0, 0. And it looks like I have a slope. There's a 1 in front of that, so I'll make it 1 over 1. So I'm going to go up 1, right 1. I think I can draw myself my line of best fit pretty well. Okay, so there's my line of best fit. Your choice if you want to add the arrows to it. Yeah, the arrows, that shows that you understand that it keeps going forever. And then my other equation is x plus y equals 6. So this is a cover method, 0 comma blank, blank comma 0. Nice thing is both of these come out to 6 and 6. So 0, 6 is up here. 6, 0 is here. So they do indeed intersect. My lines keep going forever both ways, but they do intersect. They intersect right here. So that appears to be the point 3, comma 3. That is the solution. So for this kind of problem, if you graph it, if I were looking on a graph it, and then tell me what the solution is. There'll be a blank, comma, blank in parentheses. So in the blank, comma, blank, put the 3, comma 3 or whatever it comes out to. Where the one on the test will definitely cross that 2 thing. So if you wind up getting like 2.3, comma 7.7, you made a mistake. Yeah, but this shows you made a mistake. 207 was the other one? Okay. And it was also 1 and 5. Is that right? All right, so this is on page 207. This is number 1. Solve using substitution. So these are both equal to y. So I can plug it in right here. So I'm going to get 6x minus 4 equals negative 2x plus 28. we want to start getting x by itself, so I'm going to add 2x to both sides. Those cancel. Gives me 8x. I'm going to add 4 to both sides as well. So those cancel. So it's equal to 32. Divide each side by 8. So x equals 4. Good job. So 4 is our x value. I need to figure out the y value now. All right, so I'm going to take this 4 and I'm going to plug it in either on this one or on this one. It doesn't matter. They will give you the exact same answer. I like the top one better because I don't have to deal with any negatives. 6 times 4 minus 4. So y equals 24 minus 4. So y 24 minus 4, excuse me. So I get y equals 20. So this one definitely, if this was a graphing problem, it definitely wouldn't work for us because my graph usually goes out to positive 10 and negative 10. So at 4 comma 20, that would be way off the graph. So I wouldn't give that to you as a graphing problem. And then number 5 was the other one. Is that right? Okay. Number 5. We have y equals 6x minus 4. And then I have 6x minus y equals 4. So y is equal to this. So I can plug that directly in there. Don't forget there's going to be a subtraction sign in front of it. This is where x used to live. Let's distribute a negative over the parentheses. So I get 6x minus 4, or plus 4, excuse me, equals 4. This cancels this, agree? So I get 4 equals 4. There's no longer an x or a y value, so this means something. What does this mean, my friends? It's infinite solutions because it's true. Because this is true, this means we have infinite solutions. If that was false, my friends, it would mean there's no solution. That means there would have been parallel lines if I had graphed them, okay? Friends, we feel comfortable? We're good? Happy? All's good in the hood? All right. So let's turn in our books to page 209. 209, please. I think that's it. So this is on page 209 of our book. Okay. So far we've talked about graphing, and if you can find out where they cross exactly, then we can get the solution is where they cross the xy value. We then did substitution, and substitution really works best when you can get one of the letters by itself real easily. Well, if you take a look at either of these equations, neither of my equations will allow me to solve for x or y real easily. If I solve for x or y on either of these right now, I mean, I could, but I'd have fractions to plug in, like fractions with letters and stuff. And I don't know about y'all, but I don't think that sounds fun. But do you feel comfortable that these right now are indeed two linear equations? Do you agree? We have an x, we have a y, we don't have any square roots or anything, we don't have anything raised to an exponent. So they're definitely linear equations. Okay? So I want you to think about this. And without knowing too much, if you had this kind of problem on a test without knowing anything about it, if you were just to say, hey, what happens if I add these together? I get this. Notice the y's cancel each other out, right? Oh, if I divide by 8, I wind up getting 2. So 2 is my x value. I still need to find my y value. It's kind of sweet when it sets up that way, right? It can work for all of them if they're as long as the x and y's line up with each other. Okay, so what I'm going to do with this 2 here is I'm going to pick one or the other to plug it into. I'm going to pick the second equation to plug it in, but it would still come out the same if I plugged it in the first. So I have 3 parentheses plus 6y equals 48. So that's our second equation, missing the x value, because the x value we just found out is equal to what? 2. So we're going to plug that in, do the math. 3 times 2 is 6, plus 6y equals 48. Subtract the 6 from both sides. Those cancel. 6y equals 42. Divide each side by 6. So y equals 7. So 2 comma 7 is our solution to the problem. If we had graphed those, which those would not have been pretty ones to graph, but if you could graph them really well, you would find that they would cross at 2 comma 7. Okay? Questions on that? So things to note about how this is set up. Notice my x and y are on the same side of the equal sign on both of my equations. Okay, so if you see that, that might be a good indication that you might want to use the elimination method. Okay, it's a pretty powerful method to do, but it's the third of our 3 ways that we're going to show you. There are other ways that we're not going to go into in this math class. In Algebra 2, you would actually learn how to put this into a matrix and solve it that way. But you're not in Algebra 2. Not yet. Got a year or so. May I move on to the next question? Okay. So taking a look at this first question, let me just highlight it so we know which one we're talking about. I'm talking about this one that I'm highlighting in yellow. Okay. If we look at it as it sits, does it appear if I add the 2 equations together, one of the letters is going to go away? Yeah? Yeah, so let's go ahead and add these. Yeah, the y's cancel out. So 2x plus 8x, or plus 6x is 8x. 17 minus 9 is 8. Divide each side by 8. Those cancel. X equals 1. What should I do with the 1? Yeah, we're going to make it into a parentheses. So I'm going to replace an x on one of my above equations. So maybe I'll plug it in right there. I can plug it into either of those spots. Which one you want? Top or bottom one? Bottom. Bottom? Okay. Answer's the same on both, so it doesn't really matter. Sometimes one might present a little easier. Okay, so where the parentheses are right now is where the x had been, but I know that x is equal to 1, so I'm going to plug 1 in there. Do the math. 6 times 1 is 6, plus 5y equals negative 9. Subtract 6 from both sides. 5y is equal to negative 15. Divide by 5. So I think that's y equals negative 3. So there's my answer. So it's a nice answer. It's just, I can assure you, if you were to graph that, if you did the cover method, oh my gosh, you would get like 0, comma, negative 17/5. Go ahead and try and graph that. And then you'd get 17 halves, comma 0. Those are not nice ones to graph. Okay, you feel comfortable so far? Let's look at this one. We'll do this one in the blue. Okay. It's called the addition method, so yeah. It's just you might be adding positive and negative, so, but yeah. Hey friends, if you look at this one, do you feel that if I add the 2 equations together as they sit, a letter's going to go away? Yeah, the x's go away. They're both opposites, right? We have a positive 7x and negative 7x. So those go away. So then I add 2y and 1y. There's technically a 1 right there. So I get 3y. And 10 minus 16 is negative 6. Divide each side by 3. And I think that comes out to negative 2. You agree? So now I know the y value. So what should I do with this y value? What should I do with this -2? Yeah, so I'm going to find the x. So I'm going to either plug it into this top one here or this bottom one here. Which one would you like? Top? Okay. Yeah, I like the top as well. There's no other sign. So I have 7x plus 2 parentheses equals 10. What's going to go in that parentheses, friends? -2. Cool. Do the math. 7x, 2 times -2 is -4 equals 10. Add 4 to both sides. Those cancel. Divide by 7. X equals 2. So 2 comma -2. Again, that seems like it would have graphed nicely, but my goodness, friends, if we use the cover method on it, not today, sunshine. I wouldn't want to use the cover method on those. Am I going okay? Is it seeming to be an okay way to look at these? Everyone's happy? All right, so on the next page, we're going to make it a little bit harder. A little bit harder. So take a look at these problems. Let me highlight them so we know where to focus. We'll put them in pink. I think that's pink at least. Okay, friends, if I add those together right now, does it appear that the x will cancel out or the y will cancel out? Is everyone okay that if I add those together right now, I'd get 8x plus 12y? So a letter doesn't go away, agree? All right, so there has to be another way to go through this. So let's see. I'm gonna pick the y's right now. Okay? So everyone agrees that if I add 15y to -3y, it doesn't cancel out. Agreed? But what would happen if I were to multiply the entire bottom equation by 5? So the top equation I'm going to leave as is. So I get that. The bottom equation, I go 5 times x, I get 5x. 5 times -3y is -15y. And then 5 times 20 is 100. Do those new equations appear if I add them together? What's going to go away if I add them together right now? The y's. These are going to cancel each other out. Then I'm going to get 12x equals 132. Oh, I would definitely have a calculator out on this one. But I think this is going to be 11. It's 132 divided by 12, 11? Yeah. Yay! I got lucky. I took a shot in the dark. All right. So we get 11 for our x value. Okay. So friends, what do you think I should do with this 11 here? Yeah. On our original pink problems, I'm going to plug it in for the x. So I think this is a good place. I could plug it in either, but I think the bottom equation is a little nicer because we're just directly plugging it in. So we'll take that bottom equation, and I'm just going to say, okay, well, I have 11 minus 3y equals 20. It was x, but now it's just going to be an 11. We replaced it. Subtract 11 from both sides. So I get -3y is equal to 20. Subtract 11 is 9. Divide each side by -3. So y equals -3. So that's my second answer.
It's not plus 11.
Well, originally, that's good catch. So this right here doesn't have a sign in front of it, so it's technically a positive, so I want to do the opposite to it. So sometimes you'll have the x and the y on the same side of both equations, and sometimes you might have to multiply something to make up if I have both equations so I can eliminate one of the letters. Okay? So that's basically all the steps we took right there. Looks like I have 2 more to do. Is that right? Seem good? Can I move on? Good? Happy? All right. So let's take a look at this first equation. Our first system of equations. Okay. As I look at it right now, the x and the y are on the same side of the equal sign on both. Agree? If I add them together, I'd wind up getting 7x plus 5y equals 1. That doesn't help me. So which letter looks like I could multiply? Yeah.
Multiply the bottom by 4.
Real close. I love your thinking. I do believe I'm going to multiply the bottom by 4, but is it positive 4 or negative 4?
Positive.
If I multiply by positive 4, it's going to be negative. Yeah, I want opposite values. Great thinking. All right, so if I multiply this whole bottom here by negative 4, top equation is going to stay as is. The bottom one, I'm going to get negative 20x, negative 4y equals positive 28. Ooh. Did I do that right? 2, 4, 8, negative 20, negative 4, positive 28. Okay. Hey, if I add these together, 2x minus 20x, I think is negative 18x. Positive 4y, negative 4y go away. And 8 added to 28 is 36? Is that right? How am I going to get that x by itself now? Yeah, divide each side by negative 18. Okay, make sure you get the negative in there. 36 over 18 is 2, so 36 over negative 18 has got to be negative 2. Okay, so that's my x value right there. What should I do with this negative 2, friends? Yeah, I'm going to plug it in either for that x or for that x. Which one do you want, top or bottom? Top? Okay, I like it. So the top was this. The parentheses is where x used to live. What's going to go in place of the parentheses? Negative 2. Good. So 2 times negative 2 is negative 4 plus 4y is equal to 8. Add 4 to both sides. Those cancel. So 4y equals 12. What's the last step? Divide by 4. Good. Those cancel. So y equals 3. That's my y value. There's my answer. I don't know. It kind of makes a little bit of sense. Like logically, it's one of the things, you know, if you had never seen this type of stuff before, and it was on, say, like the ACT or the SAT, your first notion on these type of problems probably would be, well, let's add them together. You add them together, like, this doesn't really do much, but now it kind of logically makes sense where you might be able to modify something. So let's take a look at our last problem for today. Okay, the x and the y are on the same side of the equal sign, agree? If I add them together right now, I'm going to get negative 8x plus 3y equals 7. Well, that certainly doesn't help us. So what do you think we should do, my friends? Perfect. Multiply the top one by negative 2. Very good. Multiply that by negative 2, so that's going to give me negative 2 times negative 3x is positive 6x. Negative 2 times positive y is negative 2y. Negative 2 times 2 is negative 4. Nothing has to happen to the bottom equation. Oh, I think this one's actually going to work out pretty nicely. If I add these together now, 6x minus 5x is 1x. 1x is the same thing as x. These cancel. Negative 4 plus 5 is 1. Oh, dude. It's always good when you get 1 for an answer. I got to plug 1 in. Oh, you multiply by 1? Really? All right. What do you think I should do with this 1? I'm going to replace it with this x or this x. Which one, top or bottom? Top. Okay. -3 times. So where that parenthesis is where x used to live. What's going to go in that place? 1. So -3 times 1 is -3 plus y equals 2. I'm going to add 3 to both sides. Cool. All right. That doesn't seem too bad. Yeah. -2 on this problem? Oh, right up at the very top? Okay. So if I go and I looked at my y's, if I add the y's together right now, I'd get 3y. Do you agree? So, but if I made the top y a -2y and added it to the bottom, a positive 2y, they become opposite values, so they'd cancel out when we add them together. But I can't just multiply the y by the -2. I have to multiply everything in that particular equation. Did that answer your question? Cool. Everyone else good? All right, so I have some plans. First off, I'm going to give you the assignment. You guys want a lot of homework tonight? Okay. All right, so how about we're going to look at this first. How about we do page 111, 1 through 6? Is that okay? Now, the second thing I'm going to get you, and I got to grab it real quick because I got to make sure what it is. So we have a final exam coming up. Agree? I'll get you one of these here in a sec. Okay. I killed a forest yesterday. You each get a packet just this big. No, I'm kidding. This is like all for all my classes. So what I would also like to do tomorrow, in the review packet, try 1 through 8. I will go over problems 1 through 8 tomorrow, so you could definitely use this. Now, here's the benefit of this review packet, my friends. If you keep this review packet and you bring it to me the day of our final, what day is our final? Do we know? It's not. Is it Thursday, maybe?
It's Thursday.
Thursday?
Yeah.
Not next Thursday, but the following Thursday, right? Am I right on that? If you bring this packet back and you could show me that everything is completed. Now, friends, I'm going to give you a little hint. We are going to complete this entire packet. I'm going to go through every problem gradually. So tomorrow I'm going to go through 1 through 8. I'd like you to try it first. Okay, obviously the homework, page 211, 1 through 6, I'm going to check off for points. You're like, oh, the review's not worth points? Well, not directly, but how this comes in as points for you, as far as the final goes, what we're going to do is myself and the other CP Algebra 1 teachers, we'll give the final. We're going to figure out how people do on the final. We're then going to say, you know what? Let's do a scale factor of this. And if you bring this back to me the day of the final, and it's filled out, don't give me the blank. It's got to be filled out, all the way filled out. That means the scale factor would go in. So let's just talk about this. Someone have a calculator or a phone real quick?
Yeah.
Let's just pretend the final is worth 100 points. I'm just making this up, okay? Let's say this is what the final is worth. Okay? Let's say you get a 73 out of 100, which is a 73% on the final. But you brought back this packet and you gave it to me and it's filled out. Well, that means I'm going to give you the scale factor. So let's say the scale factor is 1.3. Oh, okay. So I'm going to go 0.73 times 1.3. Someone have a calculator? Can do that for me, please?
0.949.
Oh, you went a little too weird. 0.73 times 1.3? Oh, actually, scale factor should be 1.03. I'm sorry. It should be 1.03. 0.03. 0.8137. So that means you would have earned an 81.37% on the final exam. Is an 81.37 better than a 73? Okay. But the way you get the scale factor is you bring this packet back. Your name is on it. At the beginning of the period of our day of our final, which you said was Thursday next week. It's different for all classes, right? Or not Thursday next week, Thursday the week after. Again, I'm asking you to try 8 problems tonight, just the very first page. I go over that tomorrow, so you make any corrections on it, so you can kind of study off of this. And then the following night, I'll probably give you the next page to do. And then we'll get through this, and you'll have it completed because of class. So you bring this saying, hey, I studied, I feel good about this. Hey, let me collect this. I collect this and say, okay, I won't necessarily know what the scale factor is right away. I have to wait till most of the classes give it before we make a scale factor. But once we make a scale factor, it's, I honestly take your grades, put it in, and I say, oh, okay, Key, you got a 73 on the final, but Key, you turn this in. That means in the grade book, I'm putting 81.37, which means the grade comes up. Oh, that sounds pretty cool. I'm in. I'm going to start over.